All right. So where I would like to kind of start the new material in the course is maybe not the most exciting place, but kind of a necessary starting point, which is how do you speak the language in physics? Our goal in this course overall is to describe the motion of objects, ultimately. But in order to do that, the first thing we have to be able to do is even be able to state the motion of an object. Like, for instance, if you want to be able to say precisely and kind of mathematically that the object is going from over here and moving up to over here, how do you actually do that? What's the terminology that you need to use to say the object was here, but then it went over here in a certain manner? And that's going to require systematically going through and giving a lot of the terminology that's going to be used in the course. And one thing that I want to say off the top before introducing the specific terminology, one thing that's going to be maybe the most different in this course from other things you've seen in the past is that when we introduce a lot of this terminology, it's going to be couched in the language of what we call vectors. So let me explain what a vector is first. We'll do an in-depth discussion of the properties of vectors later, but let me just introduce what they are. The example I have in the notes is, imagine that you're like walking down the street and you know, somebody asks you, how do I get to such and such a place from here? And they ask you for directions. Naturally, your answer is going to be something like, oh, it's 2 miles east of here. And I want you to notice something very important, very simple, but very important about that answer right away. You actually gave 2 pieces of information in order to give the person directions. You told them how far away was it, and you also told them which direction you have to go. I want you to notice, people think of like, oh, physics is all about numbers, but it's not that simple actually, because if you were restricted to just using numbers and that person asked you for directions and you said it's 2 miles from here, that's really not very useful. That's not enough. It's not enough to give that person directions. And likewise, if you want to describe the motion of an object and you just say it moved 2 miles during this experiment, that's not that useful information. We need to know which way it moved. There's more information contained in the motion of objects than just numbers, than just measurements. We also have to be able to specify which way did it go? Which way was it moving? Was it turning? Was it moving in a straight line? Was it speeding up? Was it slowing down? In order to be able to actually answer all of these questions accurately, we have to have a way that we can say not just numbers, but also directions associated with those numbers. And that's what vectors are all about. That quantity that you naturally gave in response to the directions of saying it's 2 miles east of here, that is actually a vector in the language of physics. You said it was 2 miles east. You gave not only its distance away, you also gave the direction that it has to go. So that's the first key point. And again, this is something I'll dwell on in great detail later, but that's the one key point I want to sink in this little intro video, is that most of the quantities we deal with are vectors, and vectors have 2 properties, not just a number. They have what we call a magnitude of the vector, which is like the size. In my example, magnitude would be the 2 miles. That's like how far you have to go. That's how big that thing is. And they also have direction, which that one's pretty self-explanatory. Which way do you have to go? Magnitude and direction. Those are the 2 properties of a vector. So most of these quantities that we deal with are going to have both of those, magnitude and direction. So just keep that in mind.